Stack Overflow that at its peak, it was processing a lot of data traffic from all over the world, and it was doing that with just 2 SQL Server nodes. And the reason why it was possible to do that, it was because they had 1.5 terabytes of RAM, and the database size was less than 3 terabytes of RAM. So they could basically store almost half of the entire database in RAM. And as you can see, they were processing millions, 500 millions of queries per day, and 11,000 queries per second. And in order to sustain this level of traffic, and also to make sure that you can upgrade SQL Server, which requires you to it's an operation that loses availability. They needed a separate or an additional store of data in order to supply and to supply read-only traffic while they were upgrading SQL Server. And to do that, they have their architecture, as you can see in these links that I have here. They explain how their architecture worked. They had, besides the database, they had like 2 levels of caches, an HTTP cache and also a Redis cache. So on Redis, you could basically load question and answers and comments and serve almost the entire data that you needed from Redis, and only if data was not there, you would then you had to go to the database to load it. And as you can see, they also had 2 Redis servers there, having 256 gigabytes of RAM, and they were processing billions of operations on a daily basis. And let's say that we want to replicate this, because this is a very clever design that they had there to try to cache into Redis or maybe other solution to try to cache almost everything that you have, so that you can serve it. And if you don't have it in the cache, then you can go to the database. And let's say that for that we have this structure. We have like a forum where we have a post, and the post has comments, and then you have people who can vote on those comments, and then we have also tags. So this is similar to Reddit or to other platforms where people post something, and then you can add comments to those posts. And there are many solutions we can try. Now, if you go to Reddit, you'll see that on Reddit, people from time to time, when you post something about JPA and Hibernate, you will have people telling you not to use JPA and Hibernate and to use SQL, just plain SQL instead. And the reason why I'm mentioning Reddit is because although it might be surprising for you, but 40% of the data that is used to train a foundational model is based on Reddit data. So if you enjoy your LLMs, it's because it's been trained a lot on Reddit, and whatever people discuss there, it might be taken into consideration even by an LLM when you're asking a question. So let's say that you ask an LLM about this, and the LLM suggests you to use SQL, or even not only SQL, but just plain JDBC in Java. As I said, as you can see here, this is based on the Statista. 40% of the data is taken, even more than Wikipedia, if you think about it, is taken from Reddit. So let's say that the LLM has been trained on this data, and now it suggests you to use SQL and plain JDBC to solve this problem. Now, for this presentation, you can go on GitHub and you can get the repository. So whatever I'm running in IntelliJ IDEA to run the test, you can also do it as well. So I'm going to go through several scenarios the first one is based only on JDBC or based using JDBC template, the one from Spring. And then we have Spring Data JDBC, we have Spring Data JPA with Hibernate, we have Blaze Persistence, so we have several solutions we can use. So going back here to, this is the repository. So this is, if you install it locally, it will look something like this. So let me close all that. You can see here that we have the models. I basically have the entities on different folders because I'm using different solutions to this problem. That's why you see multiple of them. Now let's take the first one. This is JDBC template demo. So we have a demo for the first use case, which is based on JDBC template. So for this one, let's take a look a little bit. First of all, let's study it a little bit. So what do we have here? We have a method. We have this method here. Let's open it. And we have a query. It's very simple. It's just plain JDBC and plain SQL. So we have a query that selects post comments, user votes, join with user vote, join with users, join with post tag, join with tag. Why do we need all those joins? Because we will have to extract all this data, because we have to feed all that data into Redis. You cannot feed there references to proxies or stuff like that. No, you have to get all the data fully and to populate on your cache, because the next time when you want to load data from the cache, you have to have everything in place there, so you no longer have to go to the database. Now if you take a look at the query, now I'm not able to see the comments, so Mateus, if you can, if there are some comments written there, you can tell me. Do you think there is a problem whenever you see a query like this? Imagine that post is a relation and post is associated to comments, but then you also have votes, and then you also have users, and then you also have tags. So do you think there is a problem when you keep on joining and joining and joining too many relations that don't necessarily follow a direct link? Like from post I can go to comments, and from comments I can navigate to, as you can see, to votes and to users. So I can go directly, like in a chain, from posts to users. But then that I cannot link it directly to post tags, because from posts I can go to post tags, but from post tags I cannot go to post comments. So what do you think will happen when we execute a query like this? Do you have any idea? Even before running it, what do you think the problem will be? If you know, let me know. That's just one problem. So there is a problem on the SQL side here. Another problem that we might have is, okay, we execute this query, but then everything in SQL is a table. So whenever you're running an SQL query, you get the data represented. The executor, the query executor, will send you the data also as a table, because in the end, the way that it reaches JDBC, the JDBC result set, it has the shape of a table, because it has rows and it has columns. So we need to transform that to something that is more object oriented, and it has a hierarchical structure. So we need a row mapper in JdbcTemplate that transforms the flat structure into a hierarchical structure. And for that we can use streams, but there is a significant amount of code that we will have to write. Now, when I wrote this, I also used Copilot to, as you can see, I have Copilot here, so it can help you, and I have IntelliJ IDEA AI assistant, and I also have Claude that I can use. But it's still a lot of manual code, no matter whether you're writing it or Claude or Copilot writes it for you. You'll have to do it every time for every single use case, and that might take time. So if there is no question on the, if there was no comment related to this, I can tell you that this can cause a Cartesian product. So we have a problem in our SQL. Also, we have a productivity problem here, because we need to write a lot of code in order to process the data from the flat structure to the hierarchical one. And let's try and see how long it takes, because now I also I'm timing the execution. So let's run it. This one, let's try to run it to see how long it takes to fetch all this data. So remember, I'm fetching 50 posts with all their comments, with all their common votes, and with all their tags. So I'm fetching all that data. So it's quite a lot of data that it has to be extracted from the database. And if I'm doing a Cartesian product, you can imagine that that result set is going to take a significant, it's going to take many records that will have to be pushed from the database to the application layer. So as you can see here, this one took like 4 seconds. 4 seconds. Now, when you have like a single query taking 4 seconds, you already have a bottleneck. So this is something that you will have to fix it. You'll have to fix it. You cannot ignore it, because clients will complain. So this is one solution. Now, as I said, there are other solutions we can investigate. This is JDBcTemplate, the simplest solution. But if you remember, I said that we also have Spring Data JDBC. So Spring has the JDBC template and it has Spring Data JDBC, which are very similar. The names are very similar. Now, JDBC template is just a wrapper over JDBC. It's a utility that Spring offers, where Spring Data JDBC, it's an implementation of the Spring Data abstraction. If you think about the CRUD repository and the repository pattern that Spring Data has, because Spring Data has Spring Data JPA, JDBC, Spring Data MongoDB, Spring Data, what else there is there, like Cassandra, probably Redis, stuff like that. And we have a solution, Spring Data JDBC. So how it looks like, first of all, let me show you how it looks like. When I'm choosing this one, as you can see here, I'm loading these posts. So let's navigate a little bit to them. This is the folder. So I have the post, and the post has, as you can see, comments and posts and comments and tags. And I'm using this mapped collection, which is from the data relational core mapping, the data JDBC, Spring Data JDBC. Now, the thing is that it's very easy to add those, and as you can see here, it looks very similar to JPA as well, and I also have user votes here. So I have an alternative way to JPA in Spring Data JDBC. So let's try to see how long it takes. All right. So remember that I'm trying to get 50 posts along with all this data, right? And I expect to get, I don't expect to get like a huge amount of queries, 4 queries, because I have those collections, and 1 extra query for to fetch the hierarchy. But when I'm running this, you will see I added here some asserts for the number of statements that are generated, because if I don't get that number of statements that I expect, I will get a failure, which is a very nice way to detect n+1 query issues and stuff like that. If you're doing it in your application, you can detect performance issues long before they become a problem. As you can see, there are lots of queries, and instead of those 4 + 1, 5 queries, I basically this solution executed over 1,100 and 100. So we had here 1,100 queries that were executed. So 1.1K, that's quite a lot. And not only that it took so long, but it also took 4.8 seconds. So at this point, we have 2 solutions. One is based on JDBC, one on Spring Data JDBC. They are very simple, but they don't perform very well. So whenever people tell you just use JDBC, just use SQL, it doesn't always give you a performance solution. So the simplest solution is not always the one which is also the most efficient. So sometimes you need something that is more established or well thought. So you need something clever. Sometimes you need something clever to address something that even the SQL standard doesn't offer, because the SQL standard by default, it doesn't offer a solution that can allow us to fetch efficiently multiple collections at once, or at least it didn't offer it in SQL 92, because that's why we end up having either an n+1 query issue, as in this case, or a Cartesian product. Both of those issues end up extracting data in more than 4 seconds. Now 4 seconds is beyond the threshold of 3 seconds. Google used to say that if you have a page that takes 3 seconds, that's fine for the user. So if it loads fully in 3 seconds, that's not a problem. Now here we have a single query that takes even more than that. If we add other things that we fetch, or also if we add rendering and other things that are needed in order to fetch a web page, that goes way beyond 5-6 seconds, and the users are not going to like that. So let's try different things. Now, if you remember, I'm not sure, let me go a little bit to the slides, because we had this solution and it didn't work well because of the Cartesian product. And then we moved to Spring Data JDBC, which also took a long time. But I'm not sure if you are aware that Spring Data JDBC, there was an article related to this technology where they say that this is the beginning of the end of the n+1. So we had this n+1, and so they have some solution for that. As you can see, it's an article published by Jens Schauder, who works on Spring Data JDBC, in 2023, so almost 3 years ago. And they have this solution here, set single query loading, which we can enable. And then we can avoid n+1 by using a single query. Now how that will work, we will see. But as you can see, you can couple it. It works with these find all methods. And unfortunately for us, it doesn't work well with our model, because we cannot use it with collections, and we cannot use nested references. So we cannot fetch post comments and comments having votes. That will not work. And so we can only fetch posts with tags and comments. So we can fetch only parts of what we want. And even then, it will not be the most efficient solution, although it's much faster than what we had before. So in order to see this, you can see here that we have this, let me see which one was this example, is this one. So you can see we have post having comments and tags, but this time comment no longer has the votes. And the way that we're fetching it, so we can see in the configuration that we're using this single query loading true. And now you can fetch it using just this find all by ID. I'm telling here the IDs. So this is just find all by ID from the CRUD repository. And because I have those mappings, when I'm running this, I can see that it takes less than 4 seconds. But so it is a solution to the previous Spring Data JPA that was suffering from n+1 query issues, but it's still, as you will see, it's still not the best. It's still not the best solution. It's also very limited. So even in this case, for us, for our problem, this is not the best solution. So in this case, it took like almost 500 milliseconds, over 500 milliseconds. So what else we have? What are the solutions we have here? I'm going to show you one which is based on Spring Data JPA. Spring Data JPA and of course Hibernate. And let me go there, because this is something that is very, very interesting. I'm not sure if you are aware of it. And whenever you're using Spring Data JPA, if you are in a transactional, let me remove those. If you're in a transactional context, usually it's in the service layer, and you are querying multiple methods, but fetching the post with comments, post with tags, comments with votes. What will happen here? we will have the same persistence context, because all these methods will share the same entity manager. So wherever they are fetching has to be merged in a single place inside the persistence context. So what will happen? The first query will fetch the post and the comments, while the tags and the votes will be proxies. The second query will fetch the post with the tags, but because we already have the post fetched before, managed and linked to the current entity manager, the tags that were fetched by the second query will just replace the collection, the proxy collection, with the actual collection. And the third query will replace all the user votes that were previously proxies with the actual collection. So what Hibernate will do a progressive merge between all these things that we are fetching. So instead of doing a Cartesian product and instead of executing 1100 queries, we are doing only 3 queries that will fetch the data that we need. And here this one calls for a debug. So here what we will do, we'll actually stop the execution. 1 second, let me add a breakpoint here because I want to display the actual time here. So let's see if there is no other breakpoint. I hope there is no other breakpoint here. Now if you want to see the queries, they are very simple. So fetch post with comments, post with tags, and the other one is fetch comments with votes. So it's not very, the queries are very simple actually. So let's set the breakpoint here, because this solution, what's interesting about it, not only that it gets me the data in less time than all the solution that I had before, but it also fetches everything that I need. So I have a huge structure that is fetched here. It doesn't have anything lazy in it, and it was fetched only with 3 queries. 3 queries that are also executing pretty fast. So as you can see here, this one took, let's see how long it took, 200 milliseconds. So remember, it used to be 4 seconds, almost 5 seconds, then 350 milliseconds, and now 200 milliseconds. So it's faster than that solution from Spring Data JDBC, that single query loading thingy. And what's interesting is not only that it's faster than that, but it's more it's better for us, because as you can see, it fetches comments, and comments have votes, and votes have users, and again the comment, and not only that I have comments, I have tags. So I have a lot of data that I can just take and push it into Redis. So the next time I don't even have to execute these queries on the database. I can load everything with a single request, load everything from Redis. So this is a very, very nice solution, and it works very fast. But what if I tell you that there is an even better solution for this? So let's go back to the slide. So this is the solution. The way that it works is the first query. First of all, you have to be in the context of the transactional context. As you can see, it's only read-only. If you are only loading data, it's a very good practice to use read-only for your read-only transaction there, because that will hint Spring to avoid doing an unnecessary flush and to discard the loaded state. So the first query fetches the post with the comments while having the tags and the user votes as proxies because they are fetch type lazy. The second one will fetch the post with the tags, and now the tags that are fetched are merged in the persistence context, and now the third one will fetch the user votes and the users. And as you can see, it takes less than all the queries that I had before. And the last one is this multi-set, which is inspired from Juke. The framework Juke implemented it, and then it was included also in Blaze Persistence by Christian Bakoff. Christian Bakoff also works on the Hibernate project, and he created this extension of JPA and Hibernate that provides additional features, which he plans on integrating progressively into Hibernate eventually. But until then, you have an open source framework, Blaze Persistence, so that can provide an even more efficient solution to this problem. Now, Blaze persistence. First of all, what it implies. In the POM XML, if we go here and search for Blaze, you will see that there are just there are some dependencies that I can just bring from Maven Central, and it's an open source project. So let's go to the demo. So we have this Blaze persistence demo, and here what we'll do, let's close the other ones. We are going to fetch this entity view. So we're not going to fetch entities. The thing is that we don't even need to fetch entities. We need to fetch something that has to go to Redis. So here I'm going to, this one looks like interface-based projection in Spring Data JPA. So we have a post view that can populate, fetch ID and title, but also extract the post comments and the tags. Tags having ID and name, and comments having ID, review, and also votes, another collection, a nested collection with users and score. So what's interesting is that now let's add the breakpoint after the execution, because I'm very much interested in seeing how long this one really took. As you can see, this one will take even less time than the JPA. So this one is going to be the fastest of all, and it's going to execute all that with a single query that doesn't even execute a Cartesian product. So there is a solution that can avoid the Cartesian product, but it requires some consideration. So let's first see how long this one took. This one took 216 milliseconds, so it's slightly faster than the JPA one. But what is very interesting here is the query itself that was executed. And as you can see, we have a query here. So let me just, actually, this is the query. So let me copy this and let me go to databases. So we have the tables here. So I'm going to jump to the query console and copy the query, format it a little bit, replace the placeholders with the actual value. So as you can see, it's a single query, but the magic is this JSON aggregation. So there are basically the queries. This is very similar to that 3 query solution, because we have one query, the one from post, another one with the tags, and another one with the votes, the comments and the votes. But instead of aggregating them in the application layer in Spring and Hibernate in the persistence context, we aggregate them in the database using JSON arrays. Now you might think that, okay, but this is not really SQL, and in fact it is actually SQL. It's not relational, but SQL is no longer relational. In fact, it hasn't been fully relational since it added support for XML. But now, since 2016, the SQL standard version 2016, that's when they added support for JSON, and now the 2019 extended the support for JSON. So now we can run this and we can get the data that we want. So you see 50 records, there's no Cartesian product, because the data, those other collections are aggregated as JSON arrays. But doing this manually, because you can also do this manually, and trying to decompose this flat structure into a hierarchical structure will take you a significant amount of time, and Blaze persistence doesn't need to do that. It works with any database, and as you can see in debug mode, because that's why I did the breakpoint here, as you can see, we now have everything properly fetched. And on the database side, that last query, although it looks like, when you take a look at that query and you go to console and you see, wow, there's so much text in it, it must work so slow, because it has so many queries that have to be aggregated. But that's not necessarily true, because for the database, what the database do, it just takes this and it parses it to understand what you need, and then it constructs a plan which you can see using explain analyze. In fact, we can go here and do an explain analyze for this, and then we will see the actual plan that is executed. And you can see here it's just standard queries using, some of them are using indexes, nested loops there, index scans, and in the end they are just simply aggregated. And you see the planning doesn't even take a long time. It took like 200 milliseconds, and I didn't invest too much time to optimize it on the database side. In fact, you can make it run even faster than I did it here. For me, I was not chasing absolute numbers here. I was just trying to demonstrate how it works from one solution to the other. So you don't necessarily have to lose anything. The only thing that I would say that the compromise that you have to do, if you're choosing this method, the only compromise is that you will have to use another open source library, or you can use Chook instead for that. Or if you don't want to use an extra library, then you can use the JPA, the Spring Data JPA one. If your ORM solution can generate queries that are more efficient than the ones that you would normally generate using Plain JDBC, why it has to be slow? Using an ORM is like using an LLM, like an agent. When you're using an agent, you're telling the agent what you want, and then you have to validate to see whether that's correct. That's the same with using ORMs. It's the same with databases. You tell what you want, and then you validate to see whether you get exactly what you expected. And if you don't get what you expected, then you have to tweak it to get exactly what you want. In fact, what I built here is the solution for the Spring Data JPA. It's not even complex if you think about it. I mean, it's pretty straightforward. It's a solution that just uses a simple service method that calls 3 queries. That's basically it. It's not something very complex that you have to keep in mind. Everything is based on the way that Hibernate works behind this thing. I think that's the most that's a thing that in the end makes all the difference. If you invest time to understand how all these frameworks and technologies, and I'm not speaking only about Spring and Hibernate, I'm speaking about database systems, about Java in general, about how LLM tools work and what you can do, how you can get the most out of them without sacrificing performance, security, compliance, governance, and other stuff. So if you invest some time to get to know these tools that we have at our disposal, I think that's going to make a lot of difference, and you are going to build solutions that are beyond the average of what can be done.